To estimate the voltage and current in a generator system, consider the following guidelines. Firstly, calculate the generator power output in watts. Convert the generator's kilowatt rating to watts by multiplying the kilowatt value by 1000. For example, 75 kilowatts becomes 75,000 watts. Secondly, determine the power factor. The power factor is a measure of how effectively electrical power is being used. This is given as 0.8. Thirdly, calculate the apparent power, which is the product of power output and power factor. Apparent power equals power divided by the power factor. In our example, apparent power equals 75,000 divided by 0.8, which equals 93,750 volt amps. Fourthly, estimate the generator voltage at minimum speed. The voltage output of a permanent magnet generator is proportional to its speed. Assume a minimum speed of 60% of the maximum speed. This is an estimation, and the actual value will vary depending on the generator. Estimate the voltage ratio corresponding to the speed reduction, which is 0.6, representing a 60% reduced speed. Fifthly, calculate the estimated voltage at minimum speed. Multiply the apparent power by the estimated voltage ratio. Voltage is approximately equal to apparent power divided by the square root of 3 times the current times the power factor times the voltage ratio. Assuming a three-phase system with a line-to-line voltage, voltage is approximately equal to 93,750 divided by the square root of 3 times the current times 0.8 times 0.6, which equals approximately 100.4 times the current, in volts. Sixthly, calculate the current drawn by the motor. Convert the motor's horsepower to watts. Multiply the horsepower rating by 746. For example, 40 horsepower becomes 29,840 watts. Calculate the apparent power of the motor. Apparent power equals power divided by the power factor, so 29,840 divided by 0.8 equals 37,300 volt amps. Using the motor's voltage, 460 volts, and assuming a unity power factor, current is approximately equal to apparent power divided by the square root of 3 times voltage. This is approximately equal to 37,300 divided by the square root of 3 times 460, which is approximately 53.5 amps. It is important to note that these calculations are estimates, and the actual values may vary depending on the specific generator and motor characteristics. It's recommended to obtain the generator serial number and consult with the manufacturer for more accurate information.